Welcome to Math Made Easy with Frida. Today we will be solving exponential equations like these. It's a pretty lengthy problem to solve. It may look easy on the screen, but it is pretty lengthy, and we will be finding the roots of the equation. Let's see now. We have a cubed plus a squared is equal to 36. Now, this exponent 3 at exponent 2. 3 is not double of 2, so it's not that simple. We can't use quadratic equation immediately. Let's just do a simple trial and error. This equation will have 3 solutions because we have the highest power as 3. So let's simply, because the number 36 is quite small, let's just say if a is equal to 1, is a statement true? So we have 1 cubed plus 1 squared. What do we get? 1 plus 1, which is 2. No, the statement cannot be true. Let's say if a is equal to 2. Let's try. We have 2 cubed plus 2 squared. That's 8 plus 4. That's 12. No, it's not true. Let's say a is equal to 3. We have 3 cubed plus 3 squared. We have 27 plus 9, which is 36. So one of the solutions is a is equal to 3. All right. Now let's just write this as a quadratic equation. A cubed plus a squared minus 36 is equal to 0. Since a is equal to 3, one of the factors is a minus 3. That means we had a minus 3 into a quadratic equation, which gave me a cubed plus a squared minus 36. We have to find this equation. So to find it, we have to divide by a minus 3 here, divide by a minus 3, right? And we find this equation here. So here we get into division of synthetic division or long division of equations like this. So let's start. So this is how we do division. A minus 3, and put the numbers in. If you don't know division, long division of equations like this, there's a coming video coming up where I will explain this process to you. So we have a to the power of 3, a squared, and we usually keep a space for a to the power of 1, and then we keep our constant. There should be a space for a to the power of 3, 2, 1, and a to the power of 0. So we always keep a space and add a 0 because we don't have a to the power of 1 in this equation. Let's start. A minus 3 goes here. A squared. A squared gives me, a squared into a gives me a cubed minus 3a squared. Then, like in our regular division, subtract, and we get 4a squared plus 0. What gives me 4a squared into a plus 4a? Will give me 4a squared minus 3 fours are 12a. Addition and subtraction, this cancels, and I get 12a minus 36. This was minus 36 plus 12. 12a minus 12 times 3 is 36. Add, and this cancels out. There's no remainder. And so this is the equation that goes in here. All right. So now a squared plus 4a plus 12 can be factored using the quadratic formula where a is equal to 1, b is equal to 4, and c is equal to 12. Let's do that in the working space. Let's find b squared minus 4ac. Here b is 4 squared minus 4 into 1 into 12, which gives me 16 minus 48, which gives me negative 32. So our equation is A will be equal to negative B, which is negative 4, plus or minus the square root of negative 32 over 2A, which is 2. So this tells us that because we have a negative under the square root, it has no real solutions. Our solutions are going to be imaginary numbers, and we will learn more about imaginary numbers in a future video. So let's get into the solutions that we find now. Imaginary number I is equal to root of negative 1. All right. So we can get the root of negative 1. Now if I have the square root of negative 32, it's actually equal to root of negative 1 into root of 32. And 32 can be factored into 2, 16, 2, 8, 2, 4, 2, and 2, which is 2 to the power of 5. Fine. The square root of negative 32 is equal to square root of negative 1 into 2 to the power 4 comes out, which is 2 squared, and root 2, which is equal to, let's substitute this with I, okay, I, imaginary number I, into 4 root 2. Now let's place this over here, all right. So A will be equal to negative 4 plus or minus 4 root 2 I, imaginary number I, over 2. This cancels to 2 and 2, and we get A is equal to negative 2 plus or minus 2 root 2 imaginary number I, and these are your remaining 2 solutions. So this simple equation, exponential equation, had 3 solutions, which is A is equal to 3 and A is equal to negative 2 plus or minus 2 root 2 I, imaginary number I. If you enjoyed this video, please give me a thumbs up, and if you want to practice every day, please subscribe to my channel as I post every day. Till next time, have a nice day.